Hello everyone, today we are back again with this topic operator, and today we will be covering the last topic, that is this some special operators. We will also understand the memory representation of a variable. So we are back again to this video and we will be covering the topic memory. So what is this memory? First of all, in our system, that is a laptop or a computer, we all have two kinds of memory. First one being the primary memory, and second one will be the secondary memory. So now, for example, you have hard disk and a RAM. So RAM is a random access memory which is accessed when an application uh, is running. For example, whenever I open a program, the example of PowerPoint, and then it is stored in the resources that a presentation need, that the PowerPoint needs, are stored in RAM. But many of the permanent resources are stored in the hard disk, that is the main memory for the for your system. So when we are executing a program, the a program usually runs in our RAM, that is random access memory. So let us take an example. If we take a variable int a, then a block of memory is in the a block of memory is reserved in the RAM whose name is a. If we give the value a with if we give the variable a value, then the value is stored inside it. Now, one more thing that we have to understand very efficiently is that every memory block, every single of the memory block has have an address. Every single block. If we have an array is something like this. We will understand this in our after videos, and every single block has some address, and also this memory block takes some memory or space. It utilizes some space to present in the memory. For example, a integer type variable usually takes 4 memory bytes, but the problem is every operating system has different sets of memory uses. Integer takes 2 memory bytes in a Linux system, but in Windows it takes 4. Now let's move to the our topic, that is some special operators. So these are the three special operator, and we will be covering these two, and this pointer operator we will be understanding afterwards in after videos. So first one being the size of operator. We have understand in our previous slide, we have understand that a memory has two important factor. First one, how much memory does it takes, that is how much memory, how much space is utilized by that variable to be present in that memory. And this and the operator and this address operator, that is where the memory block is formed in the memory, that is RAM. For example, if we want to search something in a empty room, we will just know the address of that thing. Then we will find that thing. And then if we want to carry it, we want to know how much weight does it have. Then only we can carry it. That is these two operators do. Size of operator usually help us to calculate the size of a variable, and in these ampersand operator usually help us to understand or to get the address of that operator. Now let's see the example of a of operator. So we have an integer type variable, a character type variable, float type variable, and a double type variable. So we have this size of x, size of c, and we are printing it in ampersand d, that is the integer type. These are the format specifier that are specifying that we have to print it in the integer format. So now what will be the output? Let's see this in the VS Code. So we are back again to VS Code, and now we will be programming few examples to understand the size of operator very deeply. So now let's just first of all we will include standardio.h, standio.h, and then we will write int main. Okay, and then here we will take first of all a integer type variable, and we will print integer ampersand d backslash n for better formatting, and then we will here write the operator size of a. Now let's just run it and see if it's running. Sorry for that. Here, okay, we got it right, integer 4. Now let's just take few more variables, that is of a character type C, a floating type F, and a double type D. Now let's just copy this one and print every single data type and every single data type size. Okay, I have copied it 4 times. Now we will just write character here, float here, double, and then here character C is the character type, F is the floating type, and D is the double type. So let's just run it, and here we got the output. Yes, integer 4, character 1, floating 4, and double 8. So let us understand this one. So first of all, we have taken 4 different variables of different data types. Here integer type, character type, float type, and double type. And then we are just printing every single data type size by a %d format specifier. You will say why I am using %d for every single of the data types, because here we are not printing the variable itself, but we are printing the size of that variable, which is always an integer type. The size of operator always gives an integer type as an output. So we are printing every single of them, and here it is. So currently I am using Windows operating system, and in an Windows operating system, by this example, in a Windows operating system, we can say that integer data type takes 4 data bytes, character takes 1, floating take 4, and double take 8. Okay, now let's just move to the next operator. So now we will understand this address operator. This address operator usually gives us the address of the block that we want to represent, that we want to point towards. For example, if we have a variable a and we want to address of this one, we will simply print ampersand of a. Don't confuse between bitwise and this the address operator, because bitwise and need 2 variables, that is here the ampersand and a variable here and a variable here, to execute. But this address operator is a unary operator and it takes only 1 variable after the operator. This is the difference between bitwise ampersand operator, that is bitwise and operator. So this ampersand operator simply print out the address of that operator, of the variable. We will see few examples in VS Code. 3, 2, 1, start. नहीं, अभी ना, रुको. 3, 2, 1, start. So we are back again to VS Code, and we have understand the use of the ampersand operator, which is a address operator. So now we will just take a variable int a, and then we will print it %d, comma, here's this one and a. Now let's just print this one and see what's the output here. Okay, some random numbers. So what are these numbers? Actually, these are the address of that variable. So in this program, let us understand what is happening. First of all, we are declaring a variable a. So in the RAM, there is a memory block that is reserved for that variable a, and it is named a. Here we are not assigning any value, so that memory block is empty for now. And then we also the compiler gives that memory block a address, this, and for this instance, that is for this execution, we have this address, this one. If we run it again, let's see, yes, the address is same. But if we take another variable int a b, and then we will print %d and %b, sorry for this one, yeah, okay, and then we will run it, use, okay, sorry, the format, it will be easy if it will be formatted, so we are just giving \n, and then we will run it. Yes, so you can see we have two different numbers, and in that is we have two different address of these numbers. What is an address? Address is something which we get to find something. That's the exactly what these address are used for. These address will be used afterwards in the concept of pointers a lot. We will understand those afterwards. So here we will wrap our sub series, that is the operators, which comes under the series C tutorial, and we will just give a summary, short summary for what we have covered till now on this topic, operator. On our very first video, we have covered two types of operator, that is assignment operator and arithmetic operator. We have also discussed what is an operator and how to visualize that operator. We have also give examples of both assignment and arithmetic operator, and we have discussed both of them in very details. Next up, we discussed about logical operator and relational operator. We understand that how these logical operator and relational operator are used and will be used in further videos. Also, we have done very good examples in logical and relational video operators. We have also completed few tricky examples there. Then in next video, we have covered increment operator, increment decrement operator, and conditional operator. Also in these topics, we have discussed we have discussed examples in very details, and we have also seen how conditional operator can think of its own and give a few outputs which are something like the operator operates and it gives some output. And then we discussed about in next up video, the operator 4, part 4, we have discussed about bitwise operator. It was a quite tricky topic, so it takes and it took one video of as a whole, and also it is the lengthiest video among all of them. So bitwise operator, actually we have discussed a very well detail, and if you will understand if you will watch the video twice, you can understand it very well. And in this video we have covered our special operator also. We have also discussed memory part, and also we have also visualized the memory, how the RAM and ROM interconnected, and they use, and how the program utilizes the memory. So now next up we have the topics like flow control, and we will start the flow control very soon. And also there will be a video where we will understand, in it will be a lengthy video, and we will be solving as many problems as we can. The problems will be multiple choice question, also it will be few problem related questions, and we will make that session, the programming session, very fun and also very knowledgeable. So thank you.